Hello students, I am Adit Kumar Gautam and here I will be discussing some questions on set theory. These questions will reflect your knowledge on this topic set theory. Okay, so before starting with the questions, let me recall you some of the important concepts and the symbols from the set theory. Okay, first, what is set? You know all what is set. Set is a collection. Set is a collection of well defined objects. Objects, one can say elements. Okay, doesn't matter. Elements, objects. Okay, okay. For example, if say Arjun has three friends A, B, C. So A, B, C. So these are three elements. If I close them into a curly brackets, then I can say this is a set in which the elements are friends of Arjun. So Arjun friend. Set is A, B, C. Clear? Okay. Now the symbol belong. What does it mean? It means that if I say the element is belonging to some set, here the Arjun friend set is ABC and I know A is a friend of Arjun. That means A is in the set of this. Okay. So I will write A belong to AF. Okay. Okay. Clear? So mainly we write the small letters in place of elements, which this is ABC. Okay, ABC, and capital letters to denote sets. Okay, capital letters to denote set and small letters to denote small letters to denote elements of any sets. Okay, elements of any sets. Clear? Now come to the subset. What is subset? Subset is a set. First of all, it also a set, and when we talk about subset, there must be a set given to us. Okay, example, A is any subset, sorry, A is any set. Let's say the elements of A are 1, 2, 3. Okay, now there's another set B. The elements are 2 and 3. Okay, now if I say what I say, that B is a subset of A, that means the elements in B, that means in elements, sorry, the elements in B must be inside A set. Okay, so what are the elements in B? The elements of B are 2 and 3. Does these elements belongs to A? Yes, they belongs in A. So all the elements of B are in the set A. So we say, whenever this happens, we say the B set is a subset of A, and write like this. The symbol for the subset is this. Okay, so the symbol is this. Clear? Now let's jump to our questions. Okay, so let's see the first question. So the first question says, we are given with three sets A, B and C. Okay, try to understand the question. We are given three sets A, B and C. Okay, And this information is also given to us. What this information represent? This means here in single expression the two piece of information has given. What are those? The first one is the A intersection B. A intersection B is not equal to phi. What does it mean? It means that if I have a set A and another set B, then there must be at least one common element. Okay, there must exist an element such that the element will be in A as well as in B. Okay, clear? Now the second information is given that A intersection B is a subset of C. Okay, is a subset of C. This means the subset. Okay, here this means the phi element or empty set. Empty set. Let me recall you what is empty set. Empty set is the set in which there is no element. Okay, empty set is the set when there is no element in the set. Okay, and phi set is denoted by like this, or sometimes by simple curly braces. Okay, see, there is no element. Okay, so we are given with these two piece of information. Now we have to find, okay, which of the following statements is not true. So we have to find which of the following statements is not true. So let's analyze one by one. So the first is given like B intersection C is not equal to phi. That means B intersection C is not an empty set. That means we have to show an element in B intersection C. Okay, so let's see. We know what we know. To show B intersection C is not an empty set. So we know what we know. We know A intersection B is not empty. That means there exist okay, there exist an element in A intersection B. Okay, that means there exists an element in A intersection B, say X. This means X belongs to A intersection B. Okay, this means X will also be in A, and means it will be present in both. X will be also in B. Okay, clear? Now there is the second information. What is it? That A intersection B is a subset of C. Okay, and we know the X belongs to B. Okay, X belongs to B. Simple. X belongs to B. If X belongs to B, imply X and we know the X we have chosen is like this. The X must belongs in A intersection B. Clear? So X in A intersection B and X in B. So I can say X in A intersection B and AB is a subset of C. That implies that X belongs to C. So I have shown that there exists an element such that the x belongs to C as well as x belongs to B. So easily I can say that what I can say, I know there exists. This is the symbol for there exist. Okay, symbol for there exist. Okay, so there exist x such that, okay, there exists x such that x belongs to B and x belongs to C, as we have already seen. So what this means? This means x must belong in B intersection C set. This means B intersection C is an non-empty set. This further implies that B intersection C is not phi. Clear? So our first statement is true, but we have to find out the not true statement. Okay, let's go for the second statement. Now the second statement say if A minus B contain in C. Okay, if A minus B is a subset of C, then A is a subset of C. Does this statement is true? Let's see. So A minus B is a subset of C imply A is a subset of C. True or false? We have to see. Okay, let's see. So we know what we know. Let's do this by Venn diagram. So we know in Venn diagram there is a universal set represented by a rectangular form, rectangular box. This is universal set, the capital U, and A set is here A, B set is here B, and we are talking about A minus B. So A minus B means elements that are in A but not in B. So here these elements are in A but are not in B. Okay, so this yellow part area shaded is A minus B. Simple. And it is given that it is a subset of C. Here it is given. Okay, now we have to show or to disprove that A either contain A is a subset of C or A is not a subset of C. So let's see. So one thing is given here, one thing given to us is this, and there were two information also. The first one is A intersection B is non-empty and A intersection B is a subset of C. Now we know what we know. So as we can easily see that A minus B is a subset of C. Clearly A minus B is a subset of C. Okay, now what was the question? So the question was A minus B, then either we have to show this things hold or not holds. Okay, let's come to the blackboard. So A minus B is a subset of C, and these three information are given to us. Okay, now what? So if you see from the diagram, from this Venn diagram, the A minus B is this part, as it is mentioned. A minus B is this part. Okay, is this part. Now it is a subset of C. Yes. How? Okay, it is a subset of C. Yes, because it is given. How means it is easily given to us. Okay. And we know, as we know that a minus b is a subset of C. Okay, these elements in the yellow part, elements in yellow shaded region is in C set. Okay. Now we also know this, the A intersection B is also a subset of C. Yes or not? Yes, it is. It is also given. So this means, so from this, combining both the yellow shaded part, combining both the A minus B part and A intersection B part, we will get the whole set A part. Okay, you can easily see that combining this, the yellow, combining this yellow part and combining this, the purple one, will give me the whole circle of A. That means the whole set A. Okay, this will further implies the A is a subset of C. Clear? So it is also true statement. True. Clear? Yes. So it is also true. Now check any of this. Okay, let's pick the C option. Now if you try to see here what is happening, so see, from the properties of union and intersection, I can rewrite this as C. Okay, C union A intersection B. Okay, this is just direct property I am using. So, and I already knows what I already knows, that A intersection B is already a subset of C. That means the elements in A intersection B is already in C. And we know another property, that if B, let's say x, y, z, we have x, y, two sets, and x is a subset of y. So if I try to draw a Venn diagram, that means y is bigger set and x is smaller set. Okay, so one can easily see, if I try to union them, x union y, so the bigger circle will be the answer. So y. So here is the same case where A intersection B is a subset of C. We know it is a subset of C, and union with C will result me answer C. So it is also true statement. So the only option left is this, and so we can easily see by verifying 3 of the true statement that the remaining statement must be false. So our option D is correct for this option. This is false. Okay, let's move on to the next questions. Okay, so option D is correct one. Let's move on to the next question. So next question says the two newspapers A and B. Okay, two newspapers A and B published in a city. It is known that 25% of the city population reads A. So let me we knows that the 25% reads newspaper A. Okay. This means number of population or the number of percentage reads newspaper A. Now, number of persons or the population read newspaper B is 20%. Okay, it is 20%. Now what? 8% people reads both A as well as B. That means number of people read A intersection B is equals to 8%. Clear? Okay. Further, 30% of them who reads A but not B. A but not B. What we represent by like these sets? We represent like this. This means elements of A but not in B. This means elements of A, elements of A in A but are not present in B set. Okay, clear? Clear. So from the given information, the number of people who reads A but not B is 30%. Okay, is 30%. Clear? 30%. Similarly, these are 40% who reads B but not A. So who reads B but not A is 40%. Clear? 40%. Okay. Now 50% of those who reads both A and B are into advertisements. Clear? Now let's draw a Venn diagram to make more understanding question. So first of all, start with the universal set U. Now the A newspaper and the B newspaper. Okay, so we know what we know. We easily can see that B is 20%, 20. A is what? 25. Okay, right? A is 25, B is 20. Now A intersection is 8. Okay, A intersection B is 8. Clear? Clear. Now B minus A means elements which are in A but must not be in, sorry, the elements which are in B but not be in A. In B but not in A. Clear? In B but not in A. So we subtract this 20 because there are total 20 elements in B and the common elements in A and B are 8. So we subtract 8 from this. Then we will leave with the elements which are in B but not in A. So 12. Same with this, imply elements in A but not in B will be 25 minus 8, which is 17. Now clear? Now what? The question says, now the question says, what question says? The 30% of those who reads A but not B are in advertisement. Okay, so who read A but not B are in advertisements. So the 30% of 17 will be 0.3 into 17, which is 5.1. Okay, similarly for this, the question says it is 40%. Okay, so 40% of 12, which is 40% of 12 is 4.8. Clear? Now the last piece of the question is 50% who read both A and B look into the advertisement. Now 50% means 50% of 8 means 0.5 into 8 means 4. Okay, now if we add all of these numbers, we will get 13.9 as our answer. So 13.9 means what it means? It represents the population who look into the advertisements. Clear? So there are 13.9 percentage of people who look into the advertisements. Okay, let's move to next question. So 13.9. So this question is very interesting and very this question is asking for to read it very in a analytic manner. Okay, if you leave any information behind, you are not able to solve this question. So let's begin step by step. Okay, so first information is given. What is this? What the information? The information is 200 students are there. In a class, 200 students are there, in which 120 take mathematics. So first of all, let me give you how you approach to these types of question. Whenever you get to in front of this question, you always try the approach of Venn diagram. The Venn diagram approach will reduce your calculation and other efforts. First of all, start with the universal set. So the universal set U. Okay, we know in mathematics there are 120. Okay, number of students who have mathematics 120. Okay, now what? 90 take physics. Okay, number of students who took physics is 90. So here physics and 90. Clear? Now what? Now 60 take chemistry. Okay, number of students took chemistry 60. Okay, here chemistry 60. Okay, clear? Now 50 students take mathematics and physics. Okay, mathematics and physics. So I'm just writing, not representing, because in representing this the diagram will look messier. Okay, so number of students in physics and math is 50. Okay, 50. Okay, now 43 took physics and chemistry. Physics and chemistry 43. 38 math, physics and chemistry. 38 math, physics and chemistry. 38 math, physics, chemistry. And also I think I have left behind some information, which is this: the 50 take math and chemistry also. Math and chemistry. Okay, so math and chemistry is 50. Okay, so this is all the information here given. So now we have to find out the number of students who have taken exactly one subject. Okay. So let's begin step by step. Okay. Let me write this information here. Number of students in math and chemistry is 50. Okay. Let me verify. Number of students in math and physics is 50. And math and chemistry is also 50. Physics and math and chemistry. Okay, clear? Now what? Now we are given all of these information. These are all given. Now we have to find out the number of students who have math only as their subject, physics only as their subject, and chemistry only as their subject. So let's understand the question step by step. We know the number of people in chemistry and math is 50. So this means if students has physics, math and chemistry, physics, math and chemistry, those students are also included in this number. Yes or no? Yes. So if I have to find out the number of people who have only physics and only math as their subject, those who choose number of students who choose only math and physics is equals to 50 minus 38. So what we had done here? So we have done that we eliminate those students who has physics, math and chemistry with them as their subjects. So out of 50, some of the students may be having physics, math and chemistry as well as. So I eliminate the students who has the chemistry as their subject. So the answer is 12. So these 12 students only has the math and physics as their subjects, only math and physics. Okay, so please keep this in mind, only math and physics. Here students with math and physics are there, yes, but additionally the students with math, physics and chemistry are also in there. Okay, clear? So similarly, number of students who choose math and chemistry is equals to 50 minus 12, which is 50 minus 38, which is once again 12. Similarly, number of students who choose physics and chemistry only physics and chemistry as their subject is 43 minus 38. So in all of these cases we eliminate the respected courses to find out the number of students only in math and physics. Okay, only in math and physics, only in math and chemistry, only in physics and chemistry. Clear? So this is 5. Now what? Okay, now we knows this information also. Okay, now what? Now we know that total number of students in mathematics, total students in mathematics is 120. Okay, from 120 if I subtract student with math and physics, okay, and math and chemistry. Okay, and math, physics and chemistry. Okay, so I will be remaining with the students who has math as their subjects. Okay, so only so after this the answer will be 58. So these 58 students have their maths as their subject, and these 50 students have only math as their subjects. Okay, only math students. Okay, in the similar way I can do for other subjects also. So for other subjects, so for physics the total students 90 minus total students were 90. Okay, minus students having only physics and math 12, physics and chemistry 5, and this 38 number 12, 5 and 38 I subtract. 12, 5 and 38 I subtract. This will give me what? 35. Okay, so 90 minus this will give me the 50, 55, and this will 35. Clear? Now for this only physics students, only chemistry students. The chemistry students will be, the number was 60 minus 5 minus, okay, say 38 minus 12. So 50, 55 minus 5. Okay, so now if I add them, so 58 plus 35 plus 5, this will be a 40 and 98. So the 98 students will be having the only at least have only exactly the one subject. It okay, so the 98 students has their subjects either math, either physics, or either chemistry only, or exactly just one subject they have chosen. Okay, so option D is correct for this question. Yes. So you have seen how important is uh, from if we approach the question from the Venn diagram. Okay, and always try to keep all the information straight and simple. So thank you for the session.